Okay, so I think we are now live. This is the second part of our Google Summer of Code and Code for GovTech series. The first one was called Prelude. This one is called Interlude. So it's been a few weeks since we had the students show what they were planning on working on for this summer. And now they're going to show some of their work that they've done in the past few weeks. And so far, everything's been really exciting. So we're going to mainly focus on the students, giving demonstrations of what they've been able to pull together so far. And we're going to focus on two different groups of projects. The students working on Sugarizer, the multi-platform version of Sugar and Sugar activities, and music blocks. So we have 7 interns here today, and or we have 7 scheduled today, and they will be showing demonstrations of their work for you during this event. So let's start with the Sugarizer projects. We're going to start with Samarth Bagga demonstrating Sugarizer 3D volume activity. So Samarth, if you could, unmute yourself and give us a little bit of a demonstration.
Yes, I'm just setting up. Just a second.
Okay. So if anyone needs some context, we do have you can watch the Prelude video videos, which show the music blocks projects, presentations of what they were, what their proposals were, and as well as music blocks. It's a little bit noisy.
Is my screen visible?
Yes. Awesome. Thank you so much.
Okay. So, like I mentioned in the previous meeting, my project is a 3D volume activity built on Sugarizer. So the basic features are, first of all, adding the volume in this way. We can select the type of volume we want to add from the option, and we can also select whether we want a transparent version of the volume or a default version or a version with numbers on the top. And when you have a volume with numbers on the top, then we can get the numbers on top. So we can get we can simulate a dice roll through this button. Once the volume settle down, then we get the score, which is 6 plus 8 of the numbered dice. I have 5 shapes, 6 shapes: a tetrahedron, a cube, an octahedron, a decahedron, a dodecahedron, and an icosahedron. We can also change the board background. We can change the volume colors. We can zoom in and zoom out. And we can select the remove feature to remove the volumes. So another feature of this activity is the presence functionality, where we can use this activity in a multiplayer way. We switch on the multiplayer mode, and then we join from the he joined from the other activity, and we see that we can view the board and use the board in a multiplayer fashion. The next thing I am working on for this activity is to add an accelerometer. Through this, in Android and iOS devices, if switched on, then the gravity of the entire board will shift towards the point where the device is tilting towards. So this is all about my activity. Thank you.
That's great. What was one of the most challenging things to implement? I'm just curious.
So the most challenging thing was the multiplayer functionality, because I had to share a lot of things between the users to simulate exact similar events.
Great. Yeah, thank you so much for sharing. Maybe we can move on to Utkarsh.
Yeah, sure.
Utkarsh is working on the VueJS app for Sugarizer.
So is my screen visible?
Yes.
Can you see the Sugarizer app?
Yep.
Okay, so as you already might know that my project is basically migrating the Sugarizer from the old NUJS framework to new VueJS framework to version 2. So I've done a couple of things before actually starting the migration, because this project is continued from previous year GSoC. So like this screen you are seeing, which it is already implemented, but I improved it with some micro animations, as you might see, like this loading animation and micro animation basically. This one is the oldest one, which is pretty, like, they are pretty glitchy, and like we don't have much animations in it. So I've improved that first. So like you can see, this pop-up is just popping up like that. So in the newer version I have included some animations, so it's much more interactive and much more exciting for students. Like this we have, etc. And I've also worked on the localization, improving the localization. So previously we have to do a lot of setup, like we have to set this object, and then we have to listen for this localize event, and we sometimes we have to pass the whole component. So it was very messy. So I used i18 Next View, which is particularly made for Vue, and I made localization very simple. All you have to do is just use this $T, and you have to put the string you want to use, and the app will automatically detect which language we are using, and it will automatically localize the string. So it is much more easier and much less setup, as you can see. We just have to add these lines, and we can remove all the other configuring and loading stuff in each screen. Then I also improved, as I said, the first of all the animation part, like this one, and this coloring, icon coloring part. I have already showed it in my blog. As you can see, like this is before optimization. You can see the screen, like it lags. The coloring of icon lags because it is not very efficient. So I have optimized it. So after that, you can see it colorized it instantly. So it is very intuitive, and it's responsive too very much. So I've also added a view component, which is the prompt component basically. So whenever you are not connected with the server, basically you are offline. So it will prompt you before logging off. So like this component is completely reusable. I am using this for when user logs off and he is not connected with the server. So like he will be prompted that the journal and settings will be lost, and you can log off like that. So this component is made by me. What else? Yeah, the neighborhood view. So this neighborhood view allows us to see and locate what users are on the server and what they are playing. Actually, we have a simulator to simulate users. Let me start it. Yeah, so as you can see, there are a lot of Sugarizer users, virtual users basically. Yeah, these are the users. So I have made this component in VueJS, and I've also included this search functionality. So this is chat activity. So if someone wants to join a chat, he can just enter chat, and you can see that everything is blurred except chat, and now he's gone. Yeah, so this search functionality works for user and for activities. So you can join by user or by activities. Also, there is an Easter egg that I've implemented, that you have to use this body color, and you have to search Sugarizer contributors. So after you search it, you can see all the contributors in neighborhood view. I might be there somewhere. So these are all the Sugarizer contributors. It gets updated every year. So this is a little Easter egg that I've implemented. And yeah, that's it from my side.
Yeah, thank you for your demonstration. I'm curious, what's one thing that you learned from working on this so far?
Yeah, so the most important thing, I guess, is when I started the working on the project. So I saw the code, the old code, which is written in Nano.js, which is like pretty old, like 10 years old or something, But but it works. So we don't always have to migrate, like newer technologies are coming in. But Lionel never migrated because he never thought it is needed. Like if it works, then it's good. But now we have contributors like we don't know this, we have to learn an extra step and stuff. So then we decided, okay, now we have to migrate. Otherwise the app was working pretty good with older technologies. So like we don't always have to use these newer technologies until it's necessary. So I learned that. And the other thing is simplicity basically. Sugarizer is not using any fancy webpack bundler and like fancy technologies. View 3 composition API is not, it's very simple. So anyone can get started on very easily. So you can make good things with simplicity. Like you don't have to always use up to the date technologies and frameworks and libraries. That's what I've learned, I guess.
Great, yeah, thank you for sharing that. Yeah, so that's those are our two Sugarizer projects. And please stay around if we have time at the end to have a little discussion, maybe ask a few follow-up questions. So I just got a message from Mubashir that he would like to go next because of possible network issues, which is fine. So Mubashir, maybe you can unmute yourself. So this brings us into the music blocks interns and their projects and the work that they've been doing. Mubashir has been working on musical creation and transcription assistance through generative AI. Mubashir, did you get a chance to unmute yourself?
Hear me?
Yes.
Can you see my screen?
Yes. Yeah, go ahead.
So yeah, my project was this musical transcription and assistance via generative AI, and like my mentors were Devin Ulibarri sir and Walter Bender. So the contents we are going to cover today is like we'll do a quick walkthrough of what the project was and what research I have done to use an AI tool and the React I have used to develop the in-app interface, and backend I have used Fast API, and I have recently created a PR in Music Blocks to add the MIDI import support. So first of all, the project was to develop a tool for creating music audio into MIDI files and then converting that MIDI files into Music Blocks data. So the main components of it was to first of all create an interface for recording audio or uploading an audio file, and the second part was to convert that audio into a MIDI, and the third part was to MIDI to music blocks. So the I have in the first week I did research to find the AI tools for the conversion of audio to MIDI. So I found an interesting tool, Basic Pitch by Spotify. Basically, it's an open source, and it's a lightweight neural network. It converts the audio files into MIDI files. So its accuracy is quite good compared to the others, and it's open source, and there's a community support for it as well. So for the making the front end interface for recording and uploading the audio files, I use React, and there are basically two paths. First one is for recording audio, and other one is for uploading audio. So I made the design like it's quite intuitive, and it's user like it will be very easy to use. And for backend, I have used Fast API, and the functionality I have added is to use basic pitch in the backend to convert the audio into MIDI files. And right now, as of now, I am saving those MIDI files into a folder. But in coming weeks, I will try to connect the this backend to connect it directly to music blocks, integrate it into directly music blocks. So recently, I have created a PR in music blocks, so where we are dragging and dropping MIDI files onto the canvas, and they are getting converted into music blocks. So there were a lot of challenge I faced, like the connections, adjusting connections is a bit tedious task. We need to uh, take care a lot of things, and for large MIDI files, it was getting irresponsive music blocks, like it was not able to handle large MIDI files. And the total overall challenge faced I during this project were like there were limited open source things regarding the conversion of music to MIDI files. So I found an interesting tool, Basic Pitch, and the MIDI import thing was a bit tedious task because I need to adjust the connections, and I did a testing regarding the same, and I found a lot of bugs and tried to correct those bugs. And for large MIDI files, I tried to uh, add a threshold of 100 node blocks to make it responsive. So there was in past few weeks there was a quite significant progress in audio to MIDI conversion and the front end development. And I'd like to thank my mentors, Devin Ulibarri sir and Walter Bender sir, for their constant support, and the Music Blocks community. For the detailed overview of my progress, you can check out my Medium page. For all the weeks I have loaded the progress of my GSoC journey. So you can check out my Medium account, and for the PRs, like for the MIDI import PR and for the music transcription project, you can check out my GitHub. Thank you.
Okay, this was a good overview. We'd like to see the demonstration. I think, everyone watching this would love to see how it works because it's been a really helpful tool. Are you able to do a demonstration? If not, I can.
Right now, I have joined through my window machine. Like in
Okay.
Ubuntu, internet was not working.
Okay, so I was somewhat prepared for that. So I just while you were talking, I thought that that might be the case. So I changed to the branch that you're developing in. And let me just share that. Maybe I could share my entire screen so that people can see the whole workflow. There's just like a million windows open. Simplify. Just give me 10 seconds. Okay, so let's say, so what Mubashir is working on is important for two different reasons. One is that, MIDI import itself is really handy. You can take, any MIDI off the internet and just import that. So if you're working on, for example, I have a student right now who's working on, a Take the A Train project, which is primarily like, an interactive project. So he's spending most of his time on that. At the end, he can just import some music to it without having to spend yet, another day transcribing the music. So that's great. And then the other thing that this helps with is then we can get more music blocks code, which, has, which is authentic music, and we can use that to help train a LLM. So let me demonstrate how it works. I will share my entire screen. And for some reason, I have to do this like 2 times. Okay, so I think it should be working now. Okay, so off the internet, I just found this. Take the A train. And I can download it here. And I can save it. And then I can go over here to, and find that same file. Where did I save it? Recent. Okay. And come over here. So this, now I'm on the branch, the development branch that Mubashir's on. I'm gonna just throw this in the trash because I don't need it. I can drag this in here, drop it in. It always gives us this warning because if you generate too many note blocks in music blocks, there's about 7 blocks associated with any note block that will kind of crash music blocks. And when it's done, you have this, and you can just play this. But there you have it. You have all the music from that MIDI now in here. So works like magic. Okay. Let's go on to Karan, Palan. Can you go next?
Audible?
Yes.
Yeah. Okay, so is my screen visible?
Yes.
Yeah, so as you might know, I'm working on the Music Blocks version 4. That is like the revamp of Music Blocks in React and TypeScript. So this is how it actually looks like as of now. Yeah, so we have all these features of like we can generate some code and like, yeah. So these are all the features that we have as of now. And what I am working on is like implementing this masonry framework, which includes this stack of bricks, palette, and the workspace. So I'll show you what I've been working on for the past weeks. So first of all my blogs can be found on musicblogs.net /author/Karan Palan 007. And yeah, so the first thing, the issue that we had was when I was connecting to SVGs, there was an unwanted space which was left between them. So like, so what I suggested was have a solution like this. that when a brick is X pixels away from another brick, we would get a shadow brick, and when the user leaves the brick, they would snap together, right? So, and then we also had a discussion whether we should implement SVG bricks or div bricks, because if we use div instead of SVG, we have many other features of HTML. So I created a dummy workspace for the same. So this is the SVG bricks, as you can see, and yeah, these are the bricks created using the div, and these are the bricks created using SVG and the foreign element. So yeah, so what we finally came on a conclusion is that use the foreign object element in an SVG to actually render the bricks, and that is a decision that we took. And after taking that decision, I have been working on the tree for the stack. And as you can see, I have exported all the required things like the stack state, color, GILF, etc., etc. Yeah. So what I am working on as of now is like rendering the stack through this tree and like working on the palette. So yeah, this is my update.
Okay, thank you. Karan, can you share, something you learned in the process? And I realize I forgot to ask Mubashir that, so maybe we can go back to Mubashir real quick to ask. But
Yeah,
what's
so
one thing you learned?
so the thing that I learned is like solid principles and like object-oriented programming principles. So like Music Blocks uses object-oriented programming principles. So I had to like not use the component structure of React and like create objects and like yeah, create the whole stack of tree in that way. So that is the one thing I learned while the coding period in the past 2
Okay,
weeks.
to somebody who doesn't
Yeah.
know what an object-oriented is,
Yeah, so
like
it is like a
me,
class. It is
please
okay.
explain.
Yeah, so it is a class inheritance structure basically. So like let us say we so basically let us say we have a brick. It has very many different properties. So we can basically inherit those properties. Let's say some other area of our project needs it, so we can basically inherit it from the brick section. That is what it like basically means. If that, yeah.
Yeah, thank you so much. Mubashir, can you also share what one thing that you learned so far working on this?
So basically, the most important thing I learned during this process was the this block arrangement in music blocks, how it basically works, how does the connections work, and how it basically at the end how the blocks get loaded. And one other thing I learned is when you try to do research, you will get good results. Like initially, we don't have any research like which tool we'll use, and then we did for 1 week. We did a good research, and we found one interesting tool which I shared early. This basic pitch by Spotify, which converts this audio into MIDI files.
Yeah, thank you. So next we have Abhijeet. So Abhijeet Singh has been working on musical ideation through generative AI. This is kind of more on a similar thread to what Mubashir is working on.
Yeah. So, hi everyone. Is my audible voice?
Yeah.
Yeah. Cool. So, my name is Abhijeet. So, I've been working on ABC. So, musical help students to create their musical idea directly into music blog. So, basically, what we have did is we have ABC parser. So, what? So, let me directly demo it. So, here's the parser. We have been like working on this uh, musical parser in the starting. So basically what it does is it takes ABC notation music. So basically, here's the ABC file. Basically, it's a music, a Yankee Doodle. So we'll be directly converting this to ABC music. So we just need to drag and drop this here, and so once it's dropped, it takes convert directly into music blocks. So here you could see this. So and uh, so it's playing now. I don't know if audio would be coming or not, but yeah. So it
Yeah, the audio doesn't work unless you have to. If you're in Chrome or Chromium, you can share a tab, and then we can hear the sound. Can you try that once? Yeah, reshare it.
Yeah, also share tab audio.
I noticed one peculiar thing with the output. It looked like there was an equal sign before the C.
Yeah, that might be some, I think, accidentals or something. Needs to
Yeah.
figure this.
Well, anyways, maybe press play and let's see what happens.
So yeah, so it plays. We have in like in this Google Summer of Code, we structured it out also, like the meter, set key, and all those things. Then we have also added a loop also. So if there is any loop notation in the music, it will consider those out. So that's done. Next we this week we what we try to do is, what in the end we want user to create some music, and with the help of AI. So we have been working on LLM, so to convert to directly to ABC notation. And this week we tried. So currently it's in progress. So I tried using Chat Musician, but it have lot of it requires lot of resource. So I tried to move on to smaller one, but those output are not good. So and similarly tied with 2-bit LLM. So these are not good. So this week and next on, we are going to work on the AI part. So once it's implemented, so in music blocks, you will be able to directly use AI to create music blocks and like music directly onto the music blocks. So yeah.
Great. And what was one of the most challenging things that you had to overcome to
So
get where you are
the
now?
challenging, yeah. So the challenging one was having, so currently, or ABC notation, sorry, music blocks support multiple voice. So adding multiple voice uh, was one of the challenging things. So whole thing what needs to be changed and done. So that was uh, one challenging thing.
Yeah, I think you had to kind of restructure the way you were doing things in order to get to a more elegant solution, correct?
Yeah.
Awesome. Well, thank you so much. And thank you for the appropriate choice of music. Yesterday was July 4th. Seems appropriate. Okay, so next we have a video. Actually, let's do Khadar next, since Khadar is here.
Yeah. Hello everyone, can you hear me?
Yes.
Yeah. Okay, I will share my screen.
Mm-hmm.
Yeah, I think you can see my screen.
Yes.
Yeah. Now I will be discussing about my project. Make your own lesson plans. Yeah, myself, I'm Khadar. I'm an second year undergraduate RVCA. Yeah, today's flow will be like I will be explaining the flowchart of my project, and then Devil will broadcast the video one, and then I will be explaining the next part. I have divided the past work as week 1 and week 2, and then week 3 and week 4, and I will be concluding it by saying the what is the next month work. Yeah. First, regarding coming to the flowchart, first we have to prepare the data for training our model, and then we need to train our model with this data. Like here, data means the guide of the music blocks and the lesson plans, and then we need to add new features to the music blocks to improve the user experience. Up to here, this part is done, and then generating alt text for images. Why images? Like to feel the user more interactive with the lesson plan, so we need images. First we will be generating a alt text for the images, and modifying the alt text should be in a way that the user can understand it easily, and then based on the alt text we'll be trying to generate the images, and after combining these both, yeah, we'll be getting the final lesson plan. And then now Devin will share a video, like as because I'm doing an AI project, my CPU cannot process the meeting and like the chatbot at a time. So I have shared my video. Now Devin will show them.
Yes. Actually, let me just double check to make sure I've copied the right one.
Yeah, I have sent it as video one, which is a 10-minute video, like first one. Yeah, hello everyone. Now I will be giving a live demonstration about my project in the first 2 weeks, which I have done for GSoC in basic blocks. Yeah, you can see in the first week what I did was I have created a multiple PDFs from the guide of the music blocks based on our topic. I have created a multiple PDFs. I can show you that. Yeah, here you can see the table of contents. Yeah, this is the complete guide for the music blocks. If you want to go to any topic, you can click here and you can go to any topic and you can study about it. If you want to know about pitch blocks, you can go here and you can study about pitch blocks. Or if you want to about chords, you can go here and study about chords. Yeah. What I did was, this is a big PDF. So you can see here, what I did was, I have converted this big PDF into small multiple, we can say PDFs, and for each topic, I have created a separate PDF. I can show you that. Yeah, this PDF only contains the actions block information. You can see why I have did this one was, if we provide this complete guide to our model to like process it, then our model can like miss some contents, as this is a lot of data. If we like if we provide it separate PDF, then our model can process it. Like I can show you that. Yeah, how I am going to like train my model. I am showing it. We can run Python ingest.py. This code was written by me. You can see. Now, as soon as I press enter, like it will, you can see here path. Data path, I have kept data. It will go to the first actions.pdf and it will process it. Like it will split the data into chunks, and like it will create all of my embeddings and it will process it. And it will store the information in this vector store. These vector stories are like free open source. It was platform, like we can use it. This was provided by Facebook. Yeah, it takes like nearly, we can say, like 10 to 15 seconds to process each and every PDF. You can see actions.pdf is like we have processed this one. Next it goes to the next file, adding graphics, and then it will process this, and like this it continues to the end. It will take nearly like 15 to 20 minutes to process every file. I think you got the point, like how I had trained my model. Yeah, in the first week I had did this one, and like as I have said, I have trained my model with this guide, and I have added a feature. Like now I will be explaining you about the feature. there are so many users who will be using this chatbot. So users cannot ask a music blocks question, like he can ask who is the president of India, or who is the president of America, or what is the temperature in Delhi. Like he can ask any type of questions. Now, what our model should do whenever he asks like who is the president of America, our model should not respond. Like he should say, "I'm a music blocks chatbot. Please ask music blocks question." It takes 40 to 60 seconds to respond. Like up to that time, like I will say how I have obtained this functionality. You can see here. Yeah, I have underlined this. There will be a custom prompt template for each. We can say for each chatbot, in which we can write what questions the chatbot should answer and how the chatbot should answer. Like if the user enters a question which is not related to music or music blocks, then what I have written was don't answer this. So it will give him a reply like, this is a music blocks chatbot. Please ask questions related to music blocks. Yeah, this is written. And also, like as Walter sir said, here you can see only 8 to 10 years child will be mostly using this chatbot. So he should feel interactive, and 8 to 10 years child should be capable of understanding the answer which our chatbot gave. So I have added this functionality as well. So I can show you that. Yeah, you can see. So I can answer only questions related to music and music block. So this is, since your question is about who is the president of America, I will have to say this is the music blocks chatbot, and I only answer music blocks questions. Yeah, it also says like, would you like to answer any? It says like I'm not the right chatbot for that question. Yeah. And then I have created a conversational chatbot. Like what is conversational chatbot means? Let's think. Yeah. First the user asks, like he don't know about what is pitch blocks and he want to learn. Right. Let's think the user asked about this. Yeah, up to this, I will go to the next step, to the response of the chatbot. As you can see, I have already explained, like I have created multiple blocks, and I have explained how I trained my model, and I have explained the feature which I have added. And now I am explaining this. Up to this result, I will explain like how I had trained my model with existing lesson plans. Yeah. You can see there are so many lesson plans in the, you can say, music blocks web page. This is the lesson plans which are created by Devin sir, and there are some lesson plans which are created by Walter sir as well. What I have did was, see, you can see the example which Walter sir has created. Yeah. What I did was, I have taken all those lesson plans and I have created PDFs. You can see like, yeah. This is the lesson plan for broadcast. You can see in music blocks. I have created like this type of PDFs, and then I have trained this same method as which I have trained with the guide. I have trained the lesson plans as well. And yeah, that was the second point. Like I have trained my model with the lesson plans. Now regarding the conversation, like we can see, yeah, when we ask like what is meant by pitch blocks, like it says here is the fun explanation about pitch blocks, like what are pitch blocks. Yeah. This fun explanation, if you want, we can remove it or we can keep it. Like, yeah, you can see if the chatbot has given less answer. If you want a more elaborated answer, you can type. I have given like, can you please elaborate this? Because if the user is not satisfied, then he will be like typing, can you please elaborate this? Now, what our model should be capable of remembering the previous question as well. Because if our model is not able to remember the previous question, then it cannot answer this question. So it must be like a conversational type. So I have added this feature as well in my week 2. Yeah, it takes 40 to 60 seconds to get a response. Yeah, up to then I can show you like in the I have created a music blocks repo, music blocks AI repo, in which I have updated my code, and here is like I have set up the virtual environment. I have written like how to install the code locally, and in the medium like I have written a weekly blocks of every week update. Yeah. It is giving us an elaborated answer as we have asked it. Can you please elaborate this? You can copy the answer from here and
Thank you, Khadar, for that video. Your next video is a little shorter. Can you just tell us what it's about to give us some context?
yeah, I think you can see my screen.
Yeah.
Yeah, in the week 3, like I have added a feature which was set by Devin. Like Devin suggested me to add a feature. The feature was like when the user asks the chatbot to create a lesson plan, then our model should give him some songs. Based on those songs, the user will select a song, and then our model will generate a lesson plan for the topic which the user has asked. Now I think you can play the video. Hello everyone. Now I'll be giving a live demonstration for the feature which I have added for the lesson plans. Yeah, this is the work which I have done in the week 3 and week 4 of the GSoC timeline. Yeah, up to this, yeah, we will get a response. I will tell like what is the code, like how our code will perform. First, whenever the user asks a question, it will go to this block, is generated lesson plan query block, and from this function is called. What this function will do is it will go to this and it will see whether the user is asking about to generate a query, like generate a lesson plan or not. It will see, and based on that it will print the answer. You can see I have just written, just say yes or no. If answer is yes, it will return yes, otherwise no. You can see I have printed the answer here. To know like how is our chatbot working, you can see we got the answer is yes. And then like as I have said, it will be giving us the 6 real world songs. Yeah, now I'll be stopping the video because to save the time, I will like after, as soon as the model gives the answer, I will start. Yeah, as I have said, please give me it has asked us, it gave us the table, it gave us the index, song, and why it is helpful for this. And it gave us, please give me the index of the song you want to use for generating a lesson plan. See, for the same question. Yeah, let's think I'm giving an index of 5. No, yeah, again, I will be like stopping the recording. Yeah, I'm continuing the recording. Yeah, I'm doing this because to say just to save the time. Yeah, here is a complete lesson plan which it got created. We can see it gave us the materials and the procedure, and it gave us the introduction about the topic, and then exploring the compost rhythm, and then creating a compost rhythm with music blocks. It have used the song, like we can, I don't know correct exact pronunciation, but Jambra Gitana, and then it is sharing and reflection. It had created us again another subtopic, and at last it had created an assignment, and then extension like how can this be extended, and then by following this lesson plan, the students will gain the yeah like yeah it gave us the complete lesson plan. Yeah, this was my week 3 and week 4 work.
Yeah, great work, Khadar. Yeah, and we've been using it. By we, I mean myself and some other teachers have been using it to inspire some ideas. Can you share one thing that you learned from doing this?
Yeah, as you know, like AI is a booming field right now. Like this project helped me, like I have learned about generative AI and how the LLMs will work, like how to set up the LLM locally, and also like as you've seen, I have added so many features, like our chatbot only answers the music blocks questions, like how to add those features. Like I have learned that like this project may help me in placements also, as it is an AI project. So yeah, I have learned a lot of things from this.
What was the most challenging thing?
Yeah, finding the best LLM for our project. Like initially there was Llama 2 model which was not giving us the best answers. Like afterwards, as Olama has released the Llama 3 model, yeah, finding the best LLM was very challenging. And also like as the resources are not there, so setting up the Llama 3 model in my system was really challenging. Like sometimes our system like it gets stuck, and yeah, that was a challenging part.
Great, yeah, good work so far. Look forward to seeing the progress for the rest of the summer. So next we have Ajeet Pratap Singh, who shared a video with us because Ajeet had kind of a family thing that he needed to attend to. So here it is.
Hi everyone, my name is Ajeet Pratap Singh, and the project I'm working on is to add real-time collaboration in music blocks. So I've already discussed about it in the previous presentation, but just in a brief, the collaboration project is all about adding real-time collaboration feature in music blocks so that the users of music blocks can collaborate on a project in real time. So that is the project right now I am working on, and we have made some changes in the original plan also. So the original plan to implement the collaboration project that I proposed was to create a separate space for the collaboration, and then in that particular space bring the project and start collaborating. But later on, me and my mentor, yeah, we decided to change the plan so that the collaboration happens in the original the standard workspace. So that would be a better plan. It will also be an optimized approach and a better implementation. So first of all, I would like to show you the new workflow, how the new workflow of the project will work. So the original plan was to create a separate space for the project and collaborate on that project. But in the new approach, what we will do is the collaboration space will be used for the projects and also to tackle the projects, which of the projects, for example, are being collaborated on, and we can show a list of the projects as well. So now, right now, what the new workflow will look like when we click on the collaborate button, when we click on the collaboration button, a collaboration space will appear something like that. And here we will have a project, and also a link will be generated here. So when we copy the link and paste it to another tab, the link will be navigate us to the new project in the standard workspace. And there we will be able to collaborate with our with another clients. And the only thing in the only extra thing in that particular workspace will be the collaboration part, that what because this time whatever the changes will happen in the project, those changes will be shared among all the clients. Now how those changes will be shared, I will show you just in a few minutes later. So after that, I would like to show you basic architecture. I've already talked about this architecture basically. So just an client initiate the collaboration, and another client gets the changes in real time. So for this socket part, I have already implemented a server like that. So I have a server named DMPS. First, let me clear it. Yeah. And for the demo part, like how the changes will be shared, and how the clients basically will be connected. For that part, uh, let me start my server. So here my server is started, and this is the client basically. Here is the client, this one. And now let's say I have another client and one more client. So I have basically two more clients. So when I have these two clients, for the first client, I've got this message. This client has been connected with this unique ID. That first unique ID will also be used for the room creation. We will implement a room using this first ID, and this ID is for the second client that we have got connected, this one. And for this one, here is the third ID. So now after that, let's say one of the client leaves. So if this client leaves, we will get a disconnected as well with the respective ID. So this client has left the room. So we have got the message. So this is how the clients will be connected through a socket server. And the part that we have to implement will be to track the changes, these changes. Let's say if I remove that block from here and I put that block here. So now a change has been made in the project. Now that change must be appear here in this client as well. So the part we have to implement further is that to track those changes and to send those changes to the connection to the socket server that we have already implemented this one. And after that, after tracking and sending the changes, and the next task would be to sync those changes with minimal possible latency. So that was from my side. Thank you so much.
Great. So that is all 7 of our music blocks and Sugarizer students, interns for Google Summer of Code and Code for GovTech. We're going to have the another one of these in 2 weeks. So we're going to skip next Friday, but on July 19th, we'll do the rest of the interns, the students. Walter, do you have a few words to share with everybody?
Sure. First, I just want to thank everyone for their presentations. Very interesting stuff. Regarding the Sugarizer presentations, it's great to see how mature Sugarizer's gotten, and it's nice that I think we can really start to focus on some of the questions of pedagogy and how to really exploit this great platform for lots of learning. In terms of the music blocks work, it's just super exciting to see how we can engage our learners using some of the contemporary AI tooling to help focus them on really delving into deeper and with more facility into some of the questions of music and math. We're taking a lot of the pain points away by using AI to do some of the mundane transcriptions while exposing students and teachers to more of the core ideas of music. So that overarching goal for the summer is really starting to show through, and it's I think really encouraging. But the other thing that was quite evident in all the presentations is that our interns are learning a lot, and we're learning a lot from them. So those are the true, real hallmarks of a successful Google Summer of Code project, that you learn and that we learn. And I think the same is true for the DMP project. So again, thank you, everyone. Great work, and looking forward to seeing a lot more.
Absolutely, yeah. Thank you all for coming today and showing your work. And I guess we'll all see you in the weeks ahead working on this. And then in about a month's time or so, at the end of the summer, we will do this one more time and show the final work done this summer. So again, thank you so much for sharing your time, your talents, and your insight. Okay, so on that note, goodbye, and see everyone hopefully in 2 weeks for the second part of this interlude. Okay, so it has stopped. Thank you all.